Today we are going to discuss about the chemical residues in foods, the calculation aspects. What do you mean by calculation aspects? Many times we assume certain things when we talk about the hazard associated with the risk associated with a particular hazard. So what are these assumptions? How the population parameters are taken into account, and in what way the regulatory agencies recommend certain food standards for the benefit of the stakeholders. These things we are going to discuss in today's class. So whenever we talk about the residue limits, when it comes to residue, it is the chemical residue only, foods of animal origin, or foods of vegetable or plant origin. There have been specifications. We call such specifications as maximum residue limits or maximum residue level, and these are calculated based upon certain science, certain studies. So what are those things? Which we'll understand them in detailed way in today's class. So one of the important parameters that we take into account while calculating the residue limits is the ADI. ADI stands for acceptable daily intake. What is this acceptable daily intake? In subsequent slides, I am going to discuss. On several occasions, I am going to define this ADI. Level of any residue that is allowed in the food. That's what is acceptable daily intake is. I will consume this concentration of this particular chemical residue in food along with other ingredients, and even if I consume this level throughout my expected lifetime, there is no any considerable impact on my health. This level we call it as acceptable daily intake. Daily intake, consuming, because we are talking about the food. Food contains chemical residues. The safe level of that one we are going to determine based upon the dietary intake by the humans. The level which is acceptable in the food is the acceptable daily intake. Then how this acceptable daily intake is calculated or determined? Acceptable daily intake is expressed in terms of milligrams of a particular chemical residue in the food per kg body weight of the individual. Okay, per kg of my body weight, I am going to consume these many milligrams of chemical residue, and per day. Okay, per day is very important. Okay, every day in every day's diet, that much concentration of the chemical residue that I take, but there is no health effect in me. Okay, health effect which is demonstrated not on the same day, over lifetime. This is what is acceptable daily intake is. Okay, the observation period here is the lifetime, but intake is on daily basis, and it is per kilogram of the body weight of an individual. And here the chemical is expressed in terms of milligrams. So this is what is ADI is. Milligrams per kg per day. When it is stated here, you have to understand that these many milligrams of a particular chemical hazard that we consume along with the food, okay, per kilograms of body weight of an individual, which is consumed on daily basis, is the acceptable daily intake. Acceptable daily intake is calculated or computed based on NOEL and SF. What is this NOEL? discuss again. Many times we are going to discuss this. Okay. NOEL. No observable effect level. Some people also call it as no observable adverse effect level. Okay. When we say effect, so it is a bit a qualitative one. So when we say adverse effect, that is related to a chemical substance. That's why NOEL or NOAEL, they mean the same. Okay, here in this calculation of ADI. So ADI is equal to NOEL divided by SF. What is this SF? SF stands for safety factor. Okay, why we have to take the safety factor into consideration? I'll let you know. Okay, before that, let me explain this NOEL. What is this NOEL? NOEL is no observable effect level. It is a dose. Okay, dose in milligram per kg body weight, milligram of the chemical residue per kg weight of the human individual, at which no adverse effects are observed. It is a dose. Okay, dose of a particular chemical in the food expressed in milligram per kg. After consumption of that, there is no adverse effect level. That's what is no observable effect level. Okay. Then how this NOEL is determined? NOEL is always determined in laboratory animals. Laboratory animals, you know that they are the miniature of the human being. You cannot conduct any trials on the humans. You have developed a something in the lab. You want to know its the toxicity level. You cannot test it to the humans. Okay. For that purpose, what we'll do, we will take the circumstantial evidence in the laboratory animal, and when it comes to the behavior of that chemical, that particular lab animal, okay, is just like a miniature human being. Okay, so during this such a miniature of human being, whether it is a rat or a mice that you have selected, this is what is the animal host system is, and when it is administered to these lab animals, and there are certain observations. Okay, these observations are such that upon feeding the lab animal, there should not be any observable effect or adverse effect which is observed in these animals. So what is important here is in establishing the NOEL is number one is the dose. This is what is a critical dose we mean. Second is you have to select a lab animal which is most appropriate for that particular chemical. And the third is you have to use a bioassay for the toxicological studies which is highly sensitive. Okay, most sensitive animal species and most sensitive bioassay, when you use and you observe that particular dose and you observe the effect of feeding that particular chemical compound in that animal, and you observe no effect. That is what is no observable effect level. Okay. Then what are all the things that you expect in a chronic toxicological study? Chronic toxicological study, if the chemical is hazardous to the health, okay, whether it is a human, now it is miniaturized human, that is nothing but the lab animal. In those lab animals, there is no teratogenicity, carcinogenicity, mutagenicity, immunopathological effects, endocrine disruption, or nephrotoxicity, the hepatotoxicity, all those different kinds of cytotoxicities or histotoxicities are not observed in these animals. When these animals are administered with the chemical in question, such a level you call it as no observable effect level. Okay, and for establishing of this MRL, maximum residual limit, this is very important. Without this, you cannot go further. Okay. Now you know what is that NOEL is. NOEL is you have used a most appropriate lab animal. You have used the most appropriate bioassay. Underline this bioassay. And in a chronic toxicological study, at that particular dosage, you have not found any observable effect. That's what you call it as the NOEL. And NOEL is always established in lab animals. Okay? Because you cannot conduct experiment in the humans. That's why. This has to be divided by the safety factor. So what is this safety factor? In general, this safety factor varies between 100 and 1000. Okay, say for example, you want to travel from Hassan to Bangalore. The bus fare is 200 rupees, but your parents will not give you only 200 rupees. They will give certain extra amount to you so that why they will give extra amount to you? There can be a breakdown of the bus. You may have to catch the another bus. It is what is safety money, which is not required for you. When you have to reach from Hassan to Bangalore, only 200 rupees bus fare, and you are traveling by bus, only 200 rupees are required. So additional money, whatever that is given, it is a safety factor. Okay, likewise, since we have not observed any effect in the lab animals, it does not mean that it won't cause the effect in the humans. So that's why we go for the safety factor. The safety factor is a buffering concentration of that particular chemical substance expressed in milligram per kg per day. Okay, that's what we call it as ADI now. So here the safety factor is it is unitless. It is unitless and it varies between 100 to 1000 in general as a thumb rule. Usually it is 100 only. Under certain circumstances, we use 1000 as a safety factor because our assumption is that since the study has been conducted in the lab animals and we want to be safe, okay, so we have considered bit lower threshold in case of the humans. If you can keep these points in mind, so you will definitely understand the various residue limits that have been specified for the food. Now, there is one more term that we use for these chemical residues in foods, especially foods of animal origin, is the total residue level, TRL. TRL, it is a maximum acceptable level that is calculated from the ADI. And there are certain assumptions that have been taken while calculating this TRL. That is, number one, the average, the body weight of an individual. Okay, invariably it is 60 kilograms. Okay, someone is 80 kilograms, someone is 45 kilograms, someone is 55 kilograms. If you take entire population as a whole, so invariably, as a thumb rule, we say it is 60 kilograms is the adult average weight of the human being. Okay, however, it varies from race to race, region to region. It varies. For example, Japanese have lesser than 60 kilograms of weight. Okay, while some other individuals may be having more than that. I will come to that point at the end. Okay, on an average, an adult human being, whether it is male or female, whether it is Hispanic, Spanish, Asia-African, American, Australian, British, they weigh 60 kg. We take into account. Okay. Then, total residue level, TRL, expressed in milligram per kg, Okay, kg is the weight of a human being. Milligram per kg is equal to NOEL divided by SF. I have already explained what is NOEL. I have explained the SF multiplied by 60. This 60 is the average body weight of the human into CF. What is this CF? CF is consumption factor. You specify the residue limit of chemical X for the pork, and the food here is we are referring to Saudi Arabia. It won't make any sense. The consumption factor is 0 there because no pork is consumed in there. Okay, because it is a forbidden animal. So TRL, when we talk about the total residue level, consumption is very important. Okay, you are talking about a population, you are speaking about a particular commodity. That commodity is at what level it is consumed. That's what is consumption factor. Sometimes the consumption factor will be high depending on the dietary habits of the individuals. In Karnataka, if you take the example, if you see towards the south, they consume a lot of ragi. Okay, they consume lesser volumes of the jowar or maize or whatever it is. Okay, other cereals other than ragi and wheat also. If you compare this with North Karnataka, in North Karnataka, ragi consumption is less. This is what is the consumption factor is. If you go to Punjab, the wheat consumption is more. The milk and milk product consumption is more. While if you come to the northeast, pork consumption is more. So this is the dietary habit of a community, of a region, or of a country that determines this consumption factor. When you express the total residue as milligram per kg, okay, of any chemical hazard, it is ADI. Okay, you come to the acceptable daily intake definition, NOEL upon safety factor, it is ADI into 60 into consumption factor. Clear? Now, TRL, now you know by looking into the formula, now you can define TRL. TRL is the combined residue level of the parent compound plus any harmful derivatives of that particular compound. Okay, you know that. I am talking about the endosulfan. Endosulfan is available in 3 different isomers, alpha, beta, and sulfate, sometimes diol also. Okay, these are all the variants of the same endosulfan pesticide or insecticide. Likewise, you come to the chlorpyrifos. Chlorpyrifos or chloropyrifos is having methyl and ethyl as the isomers. If you talk about the DDT has got 6 isomers. Okay, whether you consume endosulfan as an endosulfan alpha or a beta, within the body there is conversion of this endosulfan alpha or beta to the sulfate. And when it comes to the monitoring of the residues in the tissues, it is only the sulfate. But the commercial preparations that are sprayed over the crops are either endosulfan alpha or beta, or the combination. Invariably, the market preparations of endosulfan contain 70:30 alpha beta isomers of endosulfan. If you measure endosulfan alpha or beta, it is meaningless. Okay, why? By the animal metabolism, or when it comes to the human metabolism, due to phase 1, phase 2 reactions or other biochemical transformations that occur within a body, the compound has changed. The compound has changed. This is either a conversion product, a metabolic product, or a derivatized product. These are the things. And when you express the total residues should be sum of all these. When I talk about the DDT, It should be all 6 isomers of DDT. When I talk about chlorpyrifos, it should be methyl, ethyl and all together. When it is the endosulfan, it should be alpha, beta plus sulfate together. Such a residual level, we call it as a total residual level. Same thing happens in the antibiotics also. If you have infused animal administered with fluoroquinolone, such as the enrofloxacin, and there is one more commercial preparation, ciprofloxacin. But when it comes to the metabolism within an animal, there is a conversion. So they will get converted. And what is the form? Okay, is it you have infused ciprofloxacin, whether it got converted into enrofloxacin, or you have given enrofloxacin, it got converted into ciprofloxacin. Ultimately, what is there in the tissues? Okay, what is there that is secreted in the milk? What is there that is there in the egg? That's what is the total residue. When you want to express, you have to express all these isomers, the daughter compounds that are produced to express this total residue level. This is totally different from what we call it as maximum residue level. Maximum residue level is specific to a particular analyte, while a total residue level is the sum of those analytes. And again, how it is calculated? It is ADI into average body weight of the humans into the consumption factor. Okay, it's clear to you by this time. The consumption pattern of each population, each region, each country, that varies according to the socio-ethological parameters. Then you come to the next parameter, maximum residue. Okay, it's the residue level. We are talking about a particular chemical. How much is permissible? Okay, that's what is the maximum residue level is. Okay, and this is more of a regulatory term. Why it is more of a regulatory term? The regulatory agencies, they specify MRLs. If at all there is any increase, okay, we call this as a violation or a non-compliance, and such non-compliances will invite penalties, recall, or punishment to the firm that is associated with manufacturing of that particular food commodity. So here MRL is a type of enforcing type of the dosage that is there in the food. Okay, it's clear to you. Now, MRL is mostly used by regulatory agencies, and it is nothing but the maximum permissible level of a particular marker residue. Okay, particular marker residue means, say for example, I gave the example of chlorpyrifos, endosulfan, and ciprofloxacin. So, are you speaking about chlorpyrifos ethyl, chlorpyrifos methyl? That is the MRL. When it comes to the endosulfan, are you speaking with respect to the endosulfan alpha, endosulfan beta, or endosulfan sulfate? That is the MRL. It is specified for a particular analyte, and it is regulated. It is monitored. The food is monitored for these residues, and if at all there is violation, there is punishment or penalty. What I talked about. Okay. Now, this is the marker residue. Then what is the marker residue? Is the drug-related substance. What is a drug-related substance? Drug-related substance is either parent compound or its metabolites, which is feasible to be quantified by the laboratory method. Okay, now I will change my explanation. I talked about endosulfan. There should be endosulfan, alpha, beta, and sulfate MRL in the food. On the other hand, I can also have a MRL as a total endosulfan. Okay, the total endosulfan, when I say, I should specify it is alpha plus beta plus sulfate. Plus. Okay, this is not the same the way what we talked about the total residue level. Total residue level is different from maximum residue level, because maximum residue level, when we say, it is with respect to a particular analyte or its metabolite. Okay, analyte here is anything could be analyte, but parent compound or the metabolite. Okay, so that's what is the specification for the MRL. That is why, because of this reason, MRL is always lower than TRL. Okay, whenever we discuss the individual chemical hazards in our further discussions, I will still explain about this one. MRL refers to one compound in the food, while TRL refers to the total of related compounds in the food. So since MRL, we are highly specific in talking, is always lower than the TRL. Okay. Then how to go ahead with the calculations? Many times we undertake the residue risk analysis. Okay, the way we conduct the microbial risk analysis. Microbial risk analysis, I'll talk about that a little later. But at this time, at this point of time, we are discussing about the public health issues associated with the chemical hazards in the foods of animal origin. Let us define a chemical residue. Okay, what is that chemical and what is the residue? For this, you require kinetics of that particular chemical within the environment and its migration in the food chain, ultimately reaching the human being. Okay, that's what this information is, chemical residue related information we should have. Second thing, we need to establish MRL. If at all you want to establish the MRL, you should have the ADI. Okay, if you have ADI, you can establish the MRL. If at all you want to establish the ADI, you should have NOEL. Okay, you should have the diet consumption data. Okay, consumption factors. When these all things are there, obviously you can undertake the risk analysis associated with a chemical residue in foods of animal origin. Okay, come to the chemical residues. I have taken here the example of agrochemical. Okay, and in crops, because crops are used as feed to the animal. That's why I have taken the example of a crop here. Okay, crop. This crop acts as a feed to animal, the livestock, and livestock in turn acts as a source of food, either milk or meat, to the human being. So now the agrochemical here, you think that it is a pesticide. Now the question that arises is this particular chemical substance applied? This is how we have to begin our investigation. Okay, whether it is applied, is it available in the market, or sometimes before it has been used, now there is a ban, and the half-life of that particular substance is several decades. So this information we have to gather before we undertake any type of risk assessment or establishment of MRLs for those things. Okay, say for example, there is no practice at all, socio-ethological or economic conditions won't permit the use of that particular chemical, the soil is not having that particular chemical, and there are no health effects which are suggestive of that particular chemical substance. So there is no point in understanding that particular hypothetical chemical. Is it clear to you? So when we undertake such risk analysis, when we specify the MRLs, it should be in real life. It should not be something which is hypothetical. Okay, when it is anticipated in the food, then you go for specifying the residue. Okay, when it comes to the local administration or national administration. When it comes to global, obviously the global is sum of all these national specifications. This is what the job of the Codex Alimentarius Commission. Codex Alimentarius Commission does that job. So specifying the limits, okay, and other aspects. Now here, when it comes to agricultural chemicals and we want to know the risk associated with that particular chemical substance, first question we should ask, is it available? Is it applied? If at all it is applied, for what it is applied? Is it control of a disease, pest, weed, or inhibit the crops, or promote the growth of the plant? What it is? Okay. Then the other data with respect to data or information related to that particular chemical we have to gather. What are all the crops in which it is applied? Okay. Now, what are all the modes of transmission of that particular chemical compound in the nature? In the food chain, how it could arise? Okay. So, what is the consumption pattern? So, how much residue is expected in the particular commodity? And what is the risk associated with that to the human being? These are all the things that we have to take into account when we start undertaking such things. Okay, you keep one point in mind. Any chemical substance that migrates to the environment or through the food chain to the human being and is going to potentially harm the human health is regulated. And when it comes to the regulation, it is the MRL. When it comes to the MRL, there is ADI, and when there is ADI, there is NOEL. When it is NOEL, then consumption patterns. Okay, consumption factor. All these things are interrelated. And when it comes to the cumulative health impact, it is the total residue limits or levels of that particular substance that are all very pertinent in the foods of animal origin or foods of plant origin. So now it is clear to you. Now ADI is expected per kg body weight. Okay, per 1 kg body weight. And it is based on the toxicity studies in lab animals or more suitable using more suitable bioassay. ADI is an estimate. Why it is estimate? Nobody can exactly tell this is the ADI exactly, because all human beings will not behave in the same way. All lab animals will not behave in the same way, because it is a biological system that is subject to variation. So we estimate by taking the average of many things, many animals, many human subjects. That's why it is an estimate. Estimate of what? Of the amount of compound or chemical substance that can be ingested daily. Okay, every day if I eat that much, okay, over a lifetime. Okay, every day this much, but how long? Over a lifetime, but there is no any health risk to the consumers. None of my body systems are affected, nor my physical health, nor my mental health, nor my social health. They are affected or influenced by the consumption of this particular chemical in the food. That's what is acceptable daily intake. It is accepted, it's safe by you. It's safe, you consume it. That's what is acceptable daily intake. However, when we establish the ADI, we should also take into account the various ways by which such chemical hazards they migrate in the nature or they move in the food chain. Somewhere in one of the previous class, I talked about bioaccumulation process. Somewhere I talked about biomagnification process. Okay. Somewhere I talked about the elimination kinetics. Okay. So you have to take all those things into account when you express these things. Okay. Then what is a mode by which the human being gets exposed? Is it the food alone, or along with the food, water also? Say for example, certain heavy metals. It's not the source, is not the food alone. Okay, water is also a source. Then when you want to undertake the risk assessment of such particular chemical, you have to take both sources, this plus that. There can be many more routes for other chemicals. There can be dermal, there can be inhalation. Okay, such routes are also possible. So when we say acceptable daily intake, you have to take into account all those things. ADI must not exceed exposures from all sources and all compounds. Okay, this is very important. Okay, and while MRL speaks about the active ingredients concentration, okay, that we discussed earlier. So ADI is calculated per kg body weight, and for a particular chemical residue or a chemical compound in the food, we take into account these three things are very important. Number one, I discussed earlier. Now I am going to reiterate the same thing. The studies, chronic toxicity studies in the lab animals, adverse effect which is measured using the most sensitive bioassay that is known to the mankind. You cannot say that, sir, in that my lab I don't have that facility. You cannot say like that. You have to use the most sensitive bioassay. Using the most sensitive bioassay. Now, why this bioassay is required? I told you, to observe adverse health effect in the lab animal. Okay, and you have to calculate the dose. Okay, it is that particular dose at which no adverse health effect that is observed. You may ask next question, sir, what if the concentration is high? Any chemical substance, once it is consumed at a very elevated doses, obviously it is toxic. So nothing is safe. Okay, nothing is safe, but the dose matters. This is what you have studied. Okay, so that I am talking about a particular dose here in the ADI, not that compound as a whole. So when it comes to the calculation of the ADI, the dose is also equally important, and this is the dose that we calculate as the NOAEL. Okay, the third thing is the uncertainty factor. Okay, I told you earlier, uncertainty factor is nothing but the safety factor. Okay, what are the uncertainties associated with the occurrence of the health hazard? In the absence of the human studies, when we borrow the data from the lab animals, that's what is the uncertainty factor. In other words, it is the safety factor. Okay, to arrive at a particular concentration which is not harmful to the human being. That's what the uncertainty factor. Invariably, it is 100 times more than the lab animals. Okay, 100 times more. Okay, 100 times more towards what level? What side? Towards safety side. Towards safety side means if the dose in the lab animals is 1, okay, you divide this 1 by 100, then it becomes 0.01. Okay, 0.01. Why 0.01? This is the uncertainty factor. Okay, 0.01 is acceptable level. You may ask, sir, I have given it 1 milligram per kg to the mice, nothing happened. But you are saying you specify this much, okay, 0.01 to the human, because I want to take 100 times as a safety factor or uncertainty factor. This is because I have given 10 points or 10 marks or 10% to the animal, and remaining 10 to the personal difference. Okay, you know that there is something known as idiosyncrasy. So that factor, safety factor, totally 100, 1 upon 100, how it comes? It is 1 upon this 10, which is the species difference, into again 1 upon 10, that is the personal difference. Put together 10 into 10 is 100. So in the denominator 100 is nothing but the uncertainty factor that is taken into account while calculating the ADI of a chemical residue. This plot explains you have studied in pharmacology the dose response relationships. Okay, x-axis is the dose, y-axis is the response. Y-axis response in the sense incidence of adverse effects in the animals. This is the lab animal data. In the lab animal data, you have seen that starting from 0 to this concentration, you move across the x-axis, no adverse effects have been detected. That's what is the NOAEL is. But if the dose is increased beyond this, okay, where my arrow is pointing out, okay, there is increase, okay, exponential increase in the response. How? Observed by adverse health effects, behavioral changes, the histotoxicity, nephrotoxicity, cytotoxicity, hepatotoxicity, carcinogenicity, teratogenicity, genotoxicity, all those things. How we have detected this? Study A detected in the rat, okay. Study 2 in the mice, and this is in the rabbit. But you see, the first A that we established, that is more sensitive. Okay. Then second thing, the using the most suitable bioassay. The more near to this noel, that's the one that is established. Okay. Then after this, you have to add this safety factor, so that becomes the ADI. Okay. So again, to repeat, ADI per kg body weight is the mean weight of individual into ADI of the person. Okay, that's what is. And yeah, the other factors associated with that need to be taken. So how to establish the ADI? So it is again same thing, but I want to make you very clear about this concept. That's why I given this image. It is a Japanese study. They done, no? Agrochemicals. So toxicity studies they conducted in the animal. Same way it is done for all. Okay, since it was easily available to me in public domain, that's why I shown you. So no observable or observed adverse health effect level. That's what is milligram per kg per day. That's in the lab animal. You multiply this by the uncertainty factor or the safety factor. Then you calculate the ADI like this, the acceptable daily intake per kilogram, 1 per kilogram, okay, 1 kilogram of body weight. Okay, that's what is milligram per kg per day. When you have multiplied that value with the uncertainty factor, the data from lab animal has been transformed to the human now. Okay, this milligram per kg is in the human. This was in the lab animal earlier. Now you multiply it with the mean weight of adult human being, 60. So that becomes the acceptable daily intake per person. Okay, per person it is, and it is per kg. So acceptable daily intake is expressed in terms of milligram per kg per day or milligram per person per day. The difference between these two is body weight, adult body weight of a human being, and it is dependent on the race, the geographical location, and the country or a continent. Okay. So in other words to say, ADI, milligram per kg body weight of humans is equal to NOEL, that is milligram per kg body weight in the animals, divided by the safety factor. Safety factor is usually 100. Okay. Then other parameters have to be taken into account while expressing this. If at all you are expressing it to the infants or geriatrics, you have to increase the safety factor. Okay, you have to increase the safety factor by another 10, then it becomes 1000 to express this ADI. Okay, yeah, you are specifying that particular ADI for a immunocompromised individuals. Obviously, it cannot be 100. You increase again the safety factor by another 10. That's all. So the MRLs are expressed for a particular chemical substance, and it is having the regulatory significance. And how to determine this MRL? MRLs are commodity specific. I am talking about the endosulfan residues. Is it poultry as a whole, or the fat basis, or organ basis? Is it the muscle, liver, or a kidney? So likewise, these MRLs are specified, and Codex Alimentarius Commission, based on the risk assessment studies, they undertake they constitute the ad hoc groups, and these ad hoc groups they work extensively, and something that comes out as a codex standards. If at all a country has to comply with or want to establish a robust food safety system, they have to specify a limit which is still better than the Codex MRS. Means it is still lower than the Codex limit. That's what is the countries have to try to ensure the food safety within their territory. This is one example. Okay, this is a Japanese agrochemicals in the crop. Okay, that's what is a study. When it comes to the estimated intake in terms of milligram, okay, so how many different types of crops a particular individual consumes, okay, that's what has to be taken in this and has to be summed up, okay, then it has to be multiplied as a food factor to calculate the ADI, and when it comes to the per person, it has to be multiplied by the body weight. Earlier I talked about the thumb rule, universal 60 kg, but Japanese are, specifically I have taken this example because Japanese average body weight is 53.3. Okay, these things cannot be expressed just like your clinical. This is the dose for this cattle and this is the dose for this camel. It will not be given because regulatory agencies and the other the agencies, they cannot take each and every individual into account and do that. That is highly hectic, non-achievable. So for entire population, they will give the value. ADI, MRL, total residual limits, they are all a particular, in India, we have got country specific. We ignore the state differences. Okay, so likewise it is. This particular population has consumed these many plant materials, and over all these plant materials, there is application of this particular agrochemical by spraying. The maximum residue amount that is expected, this is again a epidemiological study. So this much ppm has been reported by various studies. Okay, this is the specified MRL for this commodity. MRL, you see, although analyte is one, but MRLs are different for soybean, sweet potato, particular example that I have taken here. Then food factor, I talked about some, say for example, dry soybean has been consumed more compared to just soybean. So what is the difference? This is dietary variation. Okay, the exposure, the food factor that is consumed per person per day, it is the food factor, and this is estimated food intake. Okay, this much is the intake that is anticipated by the individual. These things are taken into account while calculating the ADI, and when you transform this into a milligram per person per day, so ADI into body weight, that's how the data is presented. Then these are the one, they are important for regulatory purposes. Okay. Now risk assessment, there is a dedicated lecture on the risk assessment. Okay. So when we talk about the risk assessment, we know that there is nothing which is safe on the planet Earth. Okay. At the same time, there is nothing which is highly dangerous. What matters is the dose. Okay. How safe is a particular level? It is what is this dosage is. And when it comes to the foods of animal origin, the type of risk assessment that is taken for the dreaded chemicals, especially for the diseases such as cancer and all, that is different from the food risk assessment programs. Okay, again, this one I am going to explain in the subsequent class. So this is the basic theory that we follow when it comes to the chemical residues of pharmacological importance. Okay, the dose, the response, and somewhere from 0, if you see, as you increase the dose, the response also increases. So somewhere you have to draw a threshold. Okay. Then we have to calculate the NOEL for non-carcinogens. Again, you remember this discussion does not include the carcinogenic chemical substances. Okay. Again, let me repeat. Acceptable daily intake, tolerable daily intake. They are one and the same. So this I already explained. ADI is equal to Noel upon safety factor. Okay, this should get impregnated into your minds. Safety factor, when you want to calculate, you know how to calculate Noel lab animals. Okay, safety factor invariably 10 and 10. So it is the species barrier. This is individual variation. Special quotas. Okay, so data is not very accurate. You have a lot of doubts on the data collection. Then you put one more 10 as a safety factor. Some other extra things, or especially highly susceptible human population, you put one more 10 as a safety factor. Then it becomes, say, 10 into 10, 100, 1000, likewise. So extrapolations, several extrapolations are done, as I told you, from animal to human, diet and all. In humans, invariably we calculate all these parameters per body weight. Okay, you can also calculate based on the surface area. Okay, the various kinds of biological modeling systems, they are present. Okay, they take the physiological parameters into account to mention these dosages. Okay, however, there are a lot of variations between the individuals, between the species when it comes to the data. This variation can be attributed to the exposure, the different kinds of metabolism, the repair capacity and sensitivity. Okay, say for example, certain in pharmacology you have studied, some drugs are highly very critical in the cat. The moment when the cat gets exposed to a small dose, that dies. Okay, why? While the same thing in dogs, it is not there. When within the dog, certain breeds are sensitive to certain drugs. Okay, the species, breed, strain, geographical location variation, these are all the things. Okay, the variables, they are attributed to the genotype or a phenotype. Why only Negroes are more susceptible to the sickle cell anemia? That is related to something genetic parameter. So these are all the variables. That's why we have to increase the uncertainty factor or safety factor. And when it comes to again uncertainty, so whatever the levels we establish, they are more safer than the actual ground truth is. Okay. Then the drug to drug interactions. Here it is not the way you study in the pharmacology. When it comes to the food, and food is contaminated with the several kinds of chemical hazards, chemical to chemical interactions occur in the food, in the environment, within the animal body, and within the human body. So all these things have to be taken into account when you formulate a risk assessment study. Okay, additivity, synergism, potentiation, antagonism, these are all the interactions that occur between these molecules. So leading to either net increased effect or net decreased effect. Okay, those things have to be taken into account. And various sources of exposure also you have to take into account when it comes to the chemical residues and in foods, in particular the foods of animal origin. Whether it is a foods of animal origin or a foods of plant origin, the basic principles are same. Okay, if someone is doing the risk assessment of the wheat, the same things will apply to a pork. The same thing will apply to a egg. Same thing will apply to the other foods. Okay, and the health loss or the health risk that occurs to the human due to these residues in the food, we measure in terms of DALY. DALY. Okay. So what is DALY? After this COVID-19, this term is again, you must have understood. What is the total loss? One loss is with respect to mortality. So these many individuals, they died, one measure. The other measure is these many individuals got affected. They got affected. This we transform into a DALY, disability adjusted life year. Disability here is, disability does not mean the lack of hand, lack of leg, becoming handicapped, it is not that disability. Okay, this disability, the lost years of healthy life. Okay, say for example, one dolly is equal to one lost year of healthy life. Okay, say for example, I lose 6 months, that is half dolly. If I lose 4 months or 3 months, okay, it is 1/3 or 1/4 of the dolly that is lost. Okay, so that is what is the term that we measure the severity of a disease or severity of the health condition associated in human populations. The loss. Why we have to do this now? This is very important. Say for example, some chemical residue or infectious agent, it is this dolly is used for both the infectious and non-infectious kinds of hazards. Okay, I suffered a cold for 3 months. I suffered from cold for 1 week. Okay, take the other scenario. This particular hazard affected my vision. Okay, because of that I could not work. This has affected my respiratory system because of the constant sneezing and difficult breathing. I could not do my work. Okay, see the disabilities. This has damaged my liver this much percentage. Because of that, I could not thrive well. That is a loss. Okay, so when it comes to the dolly, this is an adjustment. There are so many infectious and non-infectious conditions. Okay, and there is so much of loss of the healthy working. So to synchronize all those things, we use this dolly. Okay, disability is a weighted. Okay, it is a parameter which is a weighted parameter. You know that it is not exact. We estimate. Okay, disability is weighted by a factor that reflects the severity of a disease. And what is the scale that we use? Scale is 0 or 1. 0 indicates perfect health. Okay, I am perfectly fine. There is no any health impact. I have not suffered from any inhibitions to work. I am perfectly resilient. That's no, it means there is no health impact at all. So the score is 0. So addition to the disease condition or a disease risk condition, the 0. 1 when there is a death. The individual is died. Over. Died means over, no death. No matter which system affected, no matter how much was the suffering. So that is 1. 1 is the highest. 0 is the lowest. And with this scale of measurement, so large number of global diseases, they are measured, especially in the arena of the global burden of the diseases. And it's one of the important aspects that is promoted by World Health Organization. Okay, and all the risks we measure in terms of dolly. Okay, then the weighted factors that I talked about earlier, so they have been given. Then life expectancy from the birth to death, if you measure, earlier the life expectancy was less, and now the life expectancy is more. Start from 1900, 2007, after 1 century. So because better healthcare, better food, better conveyance and all have increased the life expectancy. Okay, so these things we have to take into account when we calculate the risk to the population. Okay, whether it is with the risk associated with the chemical residues or risk associated with the biological hazards in the food, we have to take them into